Hey there, this is Akshandan and welcome back to a new video. And I have brought another fantastic video where we are going to together solve some interview level backend questions. First, my initial plan was to create this video for 70 questions where I was about to cover like the complete end to advanced, like beginner to advanced level backend. But when I was at 30th question, I realized that, hey, this video is becoming too long and bit boring. So I divided this complete video into some parts, and this is the first part where I'm going to solve 30 questions together, and they will be not dependent on any framework like Node, Python or Go. You can come from any background. The focus will be on the concepts and fundamentals. So it doesn't matter from which background, which programming language you are coming from. In the upcoming parts, I'll be talking about the further 40 questions. The thing was the next 40 questions are more aligned towards system design. So that's why I divided this video into two parts. The good part is I've already uploaded the list of questions that I'm going to cover on GitHub as a repository. You will also find some of the questions code in that repository. Before we start with the first question, I have created a Discord channel for us where you can ask questions, where I share resources, you can ask your doubts, and we can also plan some fun activities. If you want to have a one-on-one discussion with me, you can check out the link in the description. You can book a one-on-one meeting with me, and you can also DM me on LinkedIn if you have any query. Now, without wasting more time, let's get started and let's crack backend together. Okay, so let's start with the first question, but you need to understand that the first 20 questions will be super simple. So don't think that you're not learning anything. I have brought something for everyone. So after the 20 questions, I'm going to increase the level, and at the end, we are also going to reach to some system design architecture, some backend architectures. So don't worry, the first 20 questions will be for warm up and for those who want to crack their first job or internship for backend. But after that, I'm going to increase the level. And I do have a blackboard over here. So whenever I had to draw an architecture, I'll be using this. And I have also created a GitHub repository where I have uploaded some of the code files. Some of the questions needed me to explain you the code or write some code. So I have uploaded these codes on GitHub. Plus I have brought two more folders over here where I have brought the production grade servers, the servers which are already in production. And because some of the questions were asking about the production grade implementation. So for that, I have brought these two codes. These two codes are not live on GitHub, not public on GitHub, but if you focus on this video, you will be able to get these. Okay. Okay, so let's start with the first question, which is very simple. What is the role of a backend in a web application and how does it differ from the front end? Okay, so you need to understand that any web application you build or any mobile application also you build, you will be building two very main things. One will be your client. So client is nothing but the place or the software that is accessible to your users, right? So your mobile app, right? So your users can use this mobile app, whether this mobile app is built using React Native, Cordova or Flutter. Your users can use this, touch this, feel this, and use the application features through this window, right? This is called a client, right? Then we have a server. Server is nothing but someone else's computer on the cloud. On the internet, you are using someone else's computer to access some of the features. But why do we need this server, right? So think about a restaurant. Okay, so a restaurant is there. The end food that you get on your plate, the end food that you get, considered as the feature or the end product, right? This is the end product, right? But the chef might not be preparing this food in front of you, right? The chef goes to the kitchen. There is a kitchen, right? And the chef prepares the food in this kitchen, right? And brings it back to the restaurant in front of you on the table, right? And you only pay for this, and you are only concerned about this, right? You're concerned about the hygiene of this product. You're concerned about the look and presentation of this product, of this food, right? But you don't care how it is prepared. What all ingredients are put in this food, you don't care, right? Or you're not interested in that stuff. Similarly, whenever we build an application also, a software application also, a client is there which interacts with the user, and user is only concerned about this. User wants to see a better UI. The user wants to feel the better user experience, wants to get the best user experience, right? User does not want to see the loading always, right? So these are some of the functional and non-functional requirements. We will come to that. But user is interacting with this client. But at the backend, you also need to take care, like in restaurant, we were taking care of the hygiene and good food quality and presentation. Over here, the server, which is called your backend, the kitchen is called the backend in a restaurant system. So over here, the backend takes care about your security, right? The security of your data, privacy of your data, hashing, encryption, speed, latency, or a lot of things, right? You don't care whether your data is stored in US or India or Africa, right? You just want that your data, as soon as you open the app, your data should be loaded in like milliseconds, right? So all of that stuff is taken care by your backend system, right? So this is called your backend, and this backend takes care about for your privacy of your data. It takes care that the data should be loaded in like milliseconds and a lot of stuff. And you need to make sure that this backend is scalable. That if today you have like 100 users, but in like let's say in next 1 year your users increase to 1 million users, so your system should be scalable. It should be able to handle this data. So scalable, maintainable. It should not be like that if every month you have to maintain, or you have to put your servers on maintenance. It should not be like that. It should be easily maintainable, and your user should not be facing any downtime, a lot of downtime, right? So this is the purpose of your backend. I think if you explain this much to and this question will be asked if you are applying for internship, if you explain this much, more than enough. Okay, and how does it differ from frontend? You have already seen that frontend is the layer which user interacts with, and backend is the layer which user does not interact with, but takes care about a lot of non-functional requirements. Okay. Explain what an HTTP request is, and list the common HTTP methods, get, post, and all of that. Okay, so for that, what I'm going to do is I'm going to open Postman. Okay, and before explaining and before going to the Postman, I'll explain you one more thing. So over here, we know that there is a client, right? And there is a server. But how are these two entities going to interact with each other, right? So if I build a client over here and I build a server over here, these two needs to communicate, because user's data is accessible by the server, right? Because the user data will be stored in a database, and user need to access the data, but user is present at the client level, right? So user will go to the client will go to the server will go to the database, bring the data, server will get the data, server will send the data to your client device, and user can see it. But this whole communication system cannot just happen, right? There needs to be some protocol, there needs to be some set of rules, because if the set of rules are not defined on the internet, everyone will come out and they will use their own set of rules. Everyone will make their own set of rules, and no system will be able to communicate with each other. Client will not be able to understand server language, and server will not be able to understand the client request, right? So that's why some of the architecture, some of the frameworks have been built to define the set of rules. And one of the one of the framework is called REST, representational state transfer, right? And in this REST, we have a protocol, right? We have a protocol HTTP, hypertext transfer protocol, right? Hypertext, that means transfer protocol. So that means something is getting transferred, right? Something is getting transferred, and for that transfer, we have defined a protocol. Protocol means set of rules, and hypertext, that means some hypertext is getting transferred. Some textual information is getting transferred from one place to another, but commonly it is client to server and server to client. Okay. Similarly, we have HTTPS, which is secure. HTTP secure, right? So this is more secure protocol for transferring the same hypertext, right? So representational state transfer. Similarly, we have GraphQL also. We'll be coming to that later, but you need to understand that representational state transfer is like a framework for web communications, client to server and server to client communications. And HTTP is a protocol in this REST. In this REST, there are multiple protocols, right? But HTTP is one of the protocol, and there are some methods in this HTTP. Now you can see the hierarchy, right? At the top, we have REST, then we have HTTP, and then we have some methods. Okay. Now in these methods, we have some common methods like get, like post, like put, like patch. Okay. And we have delete, and some other common methods are also there. But get means whenever, so now let's come to the Postman. And I've also kept my Grok 3 ready. So Grok 3 over here will act as our helper. Whenever we are stuck anywhere, we are going to ask Grok 3. So we are going to use AI a lot to learn new things. Okay. So you can see that I have this Postman. Postman is just acting as your client, using which you can make API calls. Okay, API means application programming interface. I have a question for that, don't worry. But using this Postman, you can make API calls to your server. API calls mean HTTP calls to your server. Okay, so you can see that get, post, update, delete. So in the get, you only define your URL. Get means whenever you want to access some data from your server, you can define your endpoint. This is called your endpoint. Endpoint means the location of your server, location of that service in your server, right? So for now, I have this endpoint. So you can see this is my endpoint, and you can see this is HTTPS protocol. So this is my endpoint of my server. That means at this location, at this domain name, my server is located. Server is on the internet. So everything on the internet has a location, which is called the IP address. But for humans, we cannot understand IP address. We cannot remember IP addresses. That's why domain names were invented. Okay, and this is the domain name or the server location of my server, of the Postman server. And inside that, I want to access the info service. And for that info service, I want to get the object ID 1, right? So I want to get the document with ID 1. So this is your get call. In this, you do not define any body. Your body is empty. Body means whenever you want to create something. So for that, you need to pass on some information, right? I'll come to the post part. But you can see you just define this ID, and you can have infinite number of parameters. So if you go to the parameters, and if I write, let's say key, one more parameter, you can see my endpoint is appended with the another parameter. So you can have infinite like parameters. Usually the character length is of 2000 characters for an endpoint in many languages. But you can see this is how I define parameter. And if you click on send, you will get some data back. You can see you made a get request. So this is how you get the data back if you made a get call. Similarly, for the post call, everything is same. You define your endpoint. You do not define the parameters. You can, but over here mainly we define a post body. So in this post body, you can easily define a complete JSON, JavaScript object notation. You can define a complete JSON, and you can pass the data, and it will make a post call. So when you post call, you make whenever you need to create something. Let's say you are making a social media application and you want to create a new post, right? So for that, you need to pass on the complete post information, like post title, blog title, or image, or description, or who created this, when created this, everything. So that you can pass in the post body. Similarly, we have update. Some people get confused between put and patch. So let's understand what is the difference between put and patch using Grok 3. Difference between put and patch. So put used to update an entire resource. Like let's say you made a social media application where a lot of posts are there, but you want to update that complete post body, right? The complete post you want to update, then you will use put request. But most of the times you will only want one single field to be updated, right? Let's say the title, right? Let's say the description. That's just one field in that whole object, very big post object. You only want to update one single field. So for that you use patch request. So basically put and patch are both there to update your data in your server, in your database, right? Then we have delete. Let's say you want to delete this object in your database, the document in your database. Then you hit this delete call. Similarly, delete can also have parameters, and you can see you made a delete request to delete ID 1. So these are some common methods in HTTP. I know that I'm explaining you fastly, but feel free to go deeper into these things. But for this video, I cannot go very deeper into one single topic. Okay, great. What is a server and how does it handle a client request? We already saw that your server is actually your someone else's computer, and client is your device or your interface which user can interact with. Client will make a HTTP request to server, and server will make a response back. Server will send a response back. So if you want to see this one more time, you have a client, right? And client will make the correct HTTP method request to your server. Server is connected to your database and some more things also like Redis or like CacheDB. We will come to that. But let's say your client wants to access some data, get some data. So the client will make a get call, get HTTP call, and server will send the response back, right? If the client want to create new thing, then the client will make a post call and server will send a response back that, hey,
congratulations, your post is created. If client want to delete something, delete call will be made, and server will send a response that hey, your document is deleted. Okay, that's how an API call is there, and that's how it is done, right? I'll come to, okay, one more thing. So if I have to show you how this happens in like production grade applications, so in my production application, I have some routes. So this is a server application, not a client application. Okay, so for every feature, let's say I have notification or dashboard or credits or coupons or my users. So for everything, you have different gates, right? Routes are nothing but the gates to your server. So let's say I want to access user information. So I'll go to the user router, and you can see I have defined over here whether this endpoint is a post call, get call, delete call, everything, right? So in this over here, you can see that I have some middleware. I'll come to that. They have a separate question for this, but this post call is there, and you can see in the routes, you have to define all of your routes. Like for the user, I have defined /user, right? So this is redirecting to user router. So go over here, and after that /getAuth token, then it is redirecting to this function. Now this is a simple JavaScript TypeScript function, right? So this is how it is done, and you can see it is sending me the response back with the correct status code. I have a question for this, so we'll come to this. So I have a request, then the server do something like some logical things, and then sends the response back to your client. I hope this makes sense. Let's go to the next question. What is the difference between a relational DB and a non-relational database? Okay. So let's understand it again on the blackboard. So relational and non-relational. So we have two types of databases, right? Relational means your SQL. You can use PostgreSQL. You can use MySQL. You can use Oracle DB SQL, right? Then for non-relational, you have your MongoDB, you have Cassandra, you have Firestore by Firebase, right? Then you have Redis as your cache database, right? So you have lots of databases, but all of these databases are divided into two different types: relational and non-relational. Relational databases means when your schema is fixed. Your schema is fixed. Let's say an example is a user database. Let's say you want to save the information about your users. So you know that all of your users are going to have a first name, they are going to have a last name, they are going to have a date of birth, created at, that means when they joined this app, then they will have gender, right? Then they will have place, the current place. So you can see the schema is fixed. But for every user, I'm going to have this same set of features. But for NoSQL database, let's say you want to save product in your e-commerce, right? So every product can be different. Let's say for an electronics item, you will have height of the product or width or pixel, that aspect ratio, basically aspect ratio of that electronic device, watts, let's say for charging and all. It can be like which type ports, like ports available on this device, type C, type A and all that. But similarly for a furniture item, you will have weight, you will have inches or foot, right? So you can see as for the same thing product, the fields are changing, the schema is changing, right? My variables are changing, right? So this product, you cannot save it in a table format, because as the product type will increase, your table columns will increase and there will be a lot of null values, right? So this product item you need to store in a collection document database like MongoDB, like Firestore, which is saving your information in a JSON format. Like you can have your key and you can have your values, right? Here you can have height, here you can actually have the height, here you can have width, here you can actually have the width, right? And it will have a type which will say furniture, right? So if your user is seeing electronics item and if your this document is furniture, your server will not pick this furniture product, right? So similarly, under the same collection called products, you can have furniture items, you can have electronics item, you can have food items, you can have grocery items, a lot of things, right? Just this type needs to be changed and these parameters can be changed. Let me take you to one example. this is the Airbnb listings data set. So you can see that how Airbnb is saving your data of a room or of an apartment or of a property in NoSQL database called MongoDB. And you can see there are keys, listing URL, name, summary of the property, house rules, property type, room type. A lot of fields are there. Such a big document for one single property, right? This is Airbnb database schema, right? Then if I take you to the SQL, that is schema based, you can see the employee information. For every employee you will have first name, then you will have this mid-int, don't know what is this, but you have last name, department, phone number. Every employee will have these informations, right? In your case, in your application, if the schema is different for every employee, feel free to use a NoSQL database. But if I say show you the database employee, you can see it is a collection, sorry, not a collection, but it's a table of employees, and every row is defining one data point, that is one row, that means one employee, and every employee has this information, right? Awesome. So I hope you understood the difference between SQL and NoSQL, that is relational and non-relational databases. Not just MongoDB and collection document, we also have time series database where you need to store logs and analytics. We have cached databases where you need to store key value pairs for very frequently accessible data, like you can save it, you can use Redis for that, right? We'll come to that. But this is a very basic difference between relational and non-relational. Let's go to the next question. How does a backend application use environment variables and why are they important? So environment variables, so over here itself, so you can see, first of all, I cannot show you the exact env file, so because that env file has my API keys, but in your server application, you define one file called .env like this. And in this .env, this env, you can see it is grayed out. Why? Because in my git ignore, I have actually ignored this env file, because this env file you cannot send it to anyone, you cannot make it public on the internet, right? Because this env file contains your API keys, it contains your passwords or JWT secret keys, right? So that's why you cannot push this on the internet. So that's why it is automatically grayed. And over here, let's say you're using OpenAI LLM, right? So for that you will have an API key. So you can define your OpenAI API key and define your API key like this. Let's say you're using a PostgreSQL, right? So for that PostgreSQL, you will have your PostgreSQL user, right? So you can define your PostgreSQL user like this. You can define your password like this. You can define your host like this, port like this. So all of these variables needed to be in your local or the server where it is deployed, like in cloud, AWS or Azure or GCP. But it cannot be pushed to GitHub, right? It cannot be provided to everyone. Only few folks will have access to it. Okay. So this is the use of environment file. Okay, so this is the next question. What is an API and why do we use it in a backend development? So you can see the Postman. So over here itself, whatever these endpoints that we used to access some of the data, these are called the APIs itself. So if you want to see the actual API, so if I take you to my production application, we'll come to the Nest.js framework later, but let's see the first simple TypeScript application. So over here, if I show you the routes, right? So what are these? These are just the routes, but these are at the end the APIs, application programming interfaces. So whenever you make a request and you get a response and you have some middleware and you have some post body, you have some parameters, that whole thing, that whole entity object is called an API. Okay, so that API can be written in various programming languages. It can be written in Python using Django, Flask, Fast API. It can be written in Node using Nest.js, using Node.js, Express.js. It can be written using Java, using Spring Boot. It can be written using Go, using Golang. It can be written in Ruby, a lot of programming languages, right? So, but at the end, that language translates that whole API into curl, right? Now, what is curl? This is curl. Let me show you an example of curl. So curl means, yes, this is at the end how you can make an API call. If you just write this curl on your Windows terminal or in any of your terminal, you will be making an API call. You don't need Postman, you don't need Node.js or any framework. Even if you take this and put it in your terminal, your API call will be made. That means the whole loop of sending a request and getting a response will be made even using this also, because it has everything. It is defining me the method, it is defining the headers, it is defining the data, that is a post call, put call, it is defining the endpoint, everything. So this is the curl. So you use programming languages like JavaScript and Java, so because those are human readable and easily you can write it and you can modify them a lot. They are dynamic, right? But at the end, this is how it gets translated to, and this is the curl request, right? So if I go to Postman, and over here we use the Postman user interface to write the API call. But if I take you to this documentation, and you can see this is my endpoint, and if I take you to this code, you can see this is the Go code for this. If I take you to Node.js code, you can see the curl. This is the curl API call for this. If I take you to Dart, this is the HTTP method Dart code for this. Similarly, I can show you the Node.js request. This is the Node.js code for this. So at the end, it is the curl. At the end, this is the normal curl request, but you can translate it to multiple programming languages, whichever language you're using. This is the Python code for the same request. Okay, same request. So this is the API, application programming interfaces. It is used, in simple terms, it is used to access data from someone else's computer, that is called a server, in a very sophisticated manner, in a very well-defined manner. Okay. Explain what a primary key is in a database and why it is necessary. So primary key is usually, it can be there in NoSQL databases also, but primary key, this concept is coming out from the SQL, that is relational databases. So if I take you to the same employee database table, so over here you can see that this is the employee number, right? So you know that this employee number cannot be same for all like more than one employee, right? This employee number has to be unique, right? So we can say that this employee number is acting as the primary key for this row, for this employee, right? Because your roll number, your Aadhaar card number, or your phone number are unique to you. So these unique things are called primary keys, and we can use this primary keys to access this row from some other table also, right? Let's say there is salary table and you want to see the salary of an employee. So for that we need to access the employee data, right? So you can use this employee number to get to this row, right? That's why this in every table, one column is your primary key. Okay. So if I show you one code also, I'll come to this question, but over here you can see that I am creating a table for storing users, username, email, password and all. So over here you can see the ID of the user, the unique ID of the user, I'm making it as a primary key. Okay. And if I have to access this user from other post table, this post table means this user can create multiple posts on social media. So you can see that this post which is there is of which user, this user, right? So for that you need to access this user using the user ID, right? So using this user ID you can access this tables row, right? So that's why this one row in one column in every table is your primary key, and that's a unique value for that complete row, for that complete column, right? So this is the role, basically to access tables data from other table, basically to make a row unique, right? That's the importance of a primary key. What does it mean for a server to be stateless, and how does this relate to REST APIs? Okay, Blackboard. Let's use Blackboard. So stateless. So REST frameworks, right? HTTP or HTTPS, all of these methods, right? All of these protocols, right? They are stateless. They are helpful in creating stateless servers. Stateless means, let's say this is your client, right? And this is your server, right? And you want to access your user data, right? You are sending your UID is equal to, let's say 2, and you want to access your user information, right? So server will take this, get this user ID, go to the database, get your data and send it to you. But after that, server does not remember it, right? server will forget. Server will not be saving this state that, hey, Akshit asked me for accessing the user ID to data. No, it is not at all maintaining the state. It is a stateless entity, right? So the server or representation state transfers or like REST servers or HTTP servers, they do not maintain state, right? Because if they will maintain state, it will consume memory. You can connect a Redis database. You can connect it to some other cache database and other thing to maintain the state, but it is not at all required, and that is why it is called stateless servers. Similarly, all the REST APIs that you are creating using Node.js, Golang, Python, they are all getting called to stateless servers. They do not maintain state. They do not remember what you called. They will take a request, do the logical thing, return a response, done. Forget it. Okay. Your data is not stored in the server. Your data is stored in the database. That is a different thing, right? So you cannot say that, hey, but my data is getting stored. That is not getting stored in the server. That is stored in the database. That's a different whole environment. That's a different world. Okay. Great. I hope now you understand what is stateless. How do you store passwords securely in a database? So to store passwords in a database, you need to hash them, right? So if you let's go to the Blackboard once. So if your user is using a mobile app, and on this mobile app you are asking the user to put email and password. Email you can store because email is a public thing, right? Email you take, but password you cannot directly store in your database, right? Because your employees of your company, right, whose app it is, they can go on the database and they can read this password, right? They can read the email and they can log into your customer's account, right? This cannot happen. So email can be public, but password you need to first on the client side itself. It is not yet on the server, right? It is on the client side itself. You you need to hash this password using some hashing algorithms. We have base 62. So what this does is, I should not go into this base 62, but okay, this is a hashing algorithm, right? It takes your password in the string format and returns a very unique base 62 string like 62F9Z A B D Z, like this, 62 characters, right? 62 characters, and this is your password. This is a hashed password, right? And we have a key for this. Anyone who will be having this key can only get the real password, right? So this key is there in a client itself, and you need to hash your password, and this hashed thing will be saved in your server, in your database, right? This will be gone. This will go to your server, not your raw password, right? So this is possible using many libraries which are already there. So if I take you to the Grok 3, our helper for this video, password hashing algos and libraries, let's say in Node and Python. Okay, so password hashing is a critical part for securing user credentials, transforming password into fixed length string. You can see hash. We took base 62, so 62 characters string, and we have bcrypt library. So bcrypt is a library which takes your password and converts it into a hashable format using a salt. So salt is like a normal, is like a unique number that you added, and it just randomizes your hash, right? So that no one can actually predict it, right? So you can use this salt to randomize it. So bcrypt you can use, argon2 you can use, pbkdf2 you can use, password based key derivation function. These are all the hashing algorithms. You can just see how what maths they are doing. They at the end do a mathematical function on your password. That's it, right? Base 62 takes it, finds the mod, and just finds out the base 62 number for that. You will read it. I will not go deeper into this video but you have SSA256, SSA512 hashing algorithms, right? Cryptographic hash functions. So bcrypt is very famous, argon2 is very famous. Then for Python we have again bcrypt. So bcrypt is a algorithm, and some open source contributors have built Node package for it, Python package for it, right? So I hope you understood it. That's how you have to store your passwords. Basically, the answer is hashing, and name some of the hashing algorithms, some logical implementation, and your interviewer will be happy. Next question is, what is the purpose of a configuration file in a backend application? So configuration file is basically to define all of your configurations as the name defines. So if I show you the configuration file in my server, so if you go to the source, utils, constants, config.ts. So this configuration file is basically accessing all the API keys. So for OpenAI, I defined OpenAI model, which OpenAI model I want to use for my service. Embedding model, which embedding model I want to use. API key, so it fetches the API key from my environment file so that I can use this variable all across my application, my server. Right, so this file is basically defining all your configurations. For AWS, it is bucket name, access key, secret access, region, SQS URL. For Hume, it is the server, my base port, my base URL, my dev URL, prod URL, JW secret key. Now it is visible to you, but don't worry, I'm going to change it. MongoDB dev URI, prod URI, MongoDB pinecone, live kit. So you can see all of my configurations are there in my configuration file. That's it. No rocket science in this question. Let's go to the next question. How would you handle a situation where a client sends invalid data to your API? Okay. So for handling such invalid data itself, we have request validators and response validators. So if I take you to, I'll come to the Nest.js code itself because that's where I am doing it very professionally. But in this platform server, if you see, if I take you to a route, if I take you to platform route, platform user route, this is one of the APIs, and you can see, yes, request middleware, yes. So you can see over here, I wanted to create an API which will create a new user in my database, right? But this user information is coming from the client, from your mobile app or from your web app, React, Next, Flutter, anything. So I cannot just create a new user. I have to be sure that whatever the information is passed by the user, it is correct and it is validated. All the fields that I need, my database needs to fill in that database table, they are there in that JSON that user is sending. So for that, I wrapped this schema, I have a middleware, right? Middleware is just a new entity that sits between your client and server, right? And middleware validates something and then it allows the request or to be made, right? So this middleware, what is it doing? I have defined a schema, right? And using Zod package for Node, we have Zod. For Python, we have Pydantic, right? So these are just the model defining packages using which you can define some models, right? And you can see that over here I've defined a schema that, hey, I need the platform user ID, I need the email. If the email is not present, then say this, hey, a valid email is required. It will be sent to the user and bad request basically. Created at first name, last name. So this is a simple schema. In this format itself, I want the user to provide me the data, right? If the user is not providing the email, valid email is required. Not providing me the last name is required. Minimum characters, at least one character should be there, right? So this is how you can actually define your schema and you can prevent your user to take bad request or insufficient data request, like where the data is not complete, the data sent by the user is not complete, right? So this validation will be done first, and after that only it will call the controller function, which actually creates a new user. Similarly, you can define schema validators for all of your requests. Coming to the Nest.js, this actually helps me to define these validators in a much better way. So if I take you to platform organization, DTO. So DTO is data to object, right? So over here, what I have done, I have a, let me take you to this one. Yes. Yes, this is perfect. So over here, this request there is one request which had to create a new organization in my table, in my database, right? So for that, using Nest.js, which is a production ready framework for building web applications and server applications. So over here, I have class transformer, like there I had used Zod. So over here, I can define my fields. Organization name should be string, right? So if not, organization name is required, will be sent to the user, right? Organization alias was optional. So optional you can use, decorator you can use, right? Like this. So you can define it. Plus for the responses also, you can see this is a response that if my server did something, but I want the server to reply with this field itself, an array of organizations. For getting a list of organizations, it should be an array of organizations. So I want my server to reply in this particular schema itself. So you can apply validators on both request and response. I hope it makes sense. Explain the difference between authentication and authorization with a simple example. Okay, very common question, and it's an important question. So authentication and authorization. Authentication and we have authorization, right? These are two different things, different things. Authentication means that let's say this is your mobile app, and a mobile app or web app, right? Like this, and there is a server, right? There is a server, and behind this server we have our database, right? So we have a database, or we have some other service, we have third-party service, anything, right? So over here, what needs to happen? You authenticate on the application, right? You put your email password, right? So what are the different authentication systems? We have email password, we have API keys, right? We have JWT tokens, right? So various authentication systems are there. We can have phone login, right? Google, Apple login, third-party logins, social media provider logins, right? So these are all authentication systems, right? Where you need to JWT can come in authorization also. I'll tell you how. Even API keys can come into authorization. I'll tell you how. But all of these systems help you get authenticated. That hey, you are a valid user for this server, right? You can access the services in a server. Okay. If they say no, if your email is wrong, or if you have not yet signed up, then this server will ask you to sign up first, right? It will, if you have not generated an API key, it will first ask you to generate an API key first, right? So these are all authentication systems which just help you get through this locking system and reach this server, right? But inside this, once you have created an email password and you have got a JWT token, or you have got a API key, but after that there are multiple other things in your server, right? Multiple other services in your server, right? There can be two different types of databases in your server, and this is my server, right? Now the JWT which you have got, or the API key that you have got, they can be used to authorize you which all services you have access to. Let's say you have access to this two services, but rest all services you do not have access, and only this database you can access. Let's say you are an employee, right? So the API key will have that information that hey, this API key is for an employee, this JWT is for an employee. So employee cannot access company's funds, right? Only the founder of the company and investor of the company can have access to the funds table, funds service, or funds database, right? So these first layer of authentication, first layer is called the authentication, and second layer is called the authorization. Like authentication means if you have authentication, if you are authenticated to reach to the server, but after that, which are services you are authorized to access. This is the difference between authentication and authorization. Okay, so this is the next question. What's the purpose of a middleware in a backend application, and how might you use it? So let me go to the blackboard. So you need to understand that if this is my client, right, and this is my server, now in between these two I can have certain things. It can be load balancer, it can be middleware, it can be an API gateway. But for now, you just need to understand that before reaching to any of the routes, so in our server we have multiple routes. We have user route, we have organization route, we can have a post route, right? Anything we can have. Before reaching to any of these routes, we can put a middleware, right? Middleware can be an authentication middleware, it can be a validation middleware, right? So for now, you need to understand that a middleware is something that sits in the middle of client and your server, right? And can be a simple function which validates your request, which checks whether you have provided the correct API key or not, whether you have the enough balance to do a task or not, right? So if I give you an example, if I show you the code, I can show you the authentication middleware. So in my in my TypeScript application, if I go to the platform user, over here For now I have disabled it. If I go to this route, platform user, yes. So you can see I have defined certain middlewares. So for this route where I wanted to fetch the user using a user ID, I wanted to check whether the user has provided the correct JWT authentication or not. So for that I created this authentication middleware, and this fetches the token from the user request from the headers, and then it checks whether it verifies the JWT, and then it validates it whether this is not expired or not, right? Similarly, I have another middleware which checks the schema of my body, and then it checks whether all the required fields are provided or not, and then only if it is validated, then only it allows me to go to the controller function, which is the next layer in our server for doing certain tasks, right? Great. That's what middleware does, right? You need to explain this with some examples. How would you design a simple database schema for a blog with users, posts, and comments? So for this, I took a reference of an SQL database itself. I am designing a structured database for this. So I have already completed this question for you. So if you go on my GitHub repository and check 14_blog schema.sql file in solutions folder, you will see that I have created these SQL queries, which are going to create 3 tables: user table, post table, that means blogs table, and the comments table, right? So for this, you can see ID is primary key, username, email, password I'm storing in the hash, profile picture will be a string, bio will be text, and created at, right? And you can see username should be unique. So this is how you write SQL queries. I've already created a video on solving 70 SQL questions. To check that out. And then I have second table. Again, ID is my primary key, user ID, title, slug means like in your blog, the URL, let's say it is www.akshadhanblog.com/blog ID. So that ID will be, very non-human readable. So you can define a slug so that human can read that URL. Let's say the URL will be www.akshadhanblog.com blog is equal to agent LLM evaluation, right? So this is the slug. So I basically replace the whole string with a slug, which will be unique for every blog, right? So using this also you can access the blog, the content of the blog, featured image, that means the banner, tags, published, created, and some foreign key. So you can see I'm using the foreign key because every blog will be published by an admin, by a user. So you need to attach this user with this user table. So using that, you can use foreign keys. Then I have the comments. So comments will also be attached to a blog because every blog will have some comments. Now over here you can see delete cascade. So what is the meaning of this? This actually means that if my blog is deleted, if my post is deleted, then also delete all of its children entities. So all the comments for that blog will also be deleted. Over here also you can see this delete cascade is there. So if my user is deleted, then also delete all of its blogs and posts. Okay. So this is the meaning of this cascade. Otherwise, this is a very simple 3 SQL queries that I've written to create 3 tables with all of these columns. So yeah, that's it. Let's go to the next question. What are the HTTP status codes and what do 200.404 and 500 specifically mean? So I told you that in our request response mechanism over here, client sends a request, right? And server sends a response back. Right? So every response has a status code also. 200 means your response is successful and whatever you wanted to get, you have got it. So this means success. Okay. 404 is again a famous status code, which means not found. You must have seen this at some pages, right? 404 not found. 400 means bad request. That means server wanted some things which you did not provide in the request body. So what I've done is, if you see the same repository 15_statuscode.json, I've already provided you all the famous status codes and what do they actually mean. You can actually give it a read, and this much is like more than enough. Like no interviewer will himself remember all of this. So these status codes are enough. Just give it a lighter read. Okay. So this is the meaning of status code. Just depicts the status of your response of your API call. How would you write a basic API endpoint to retrieve a list of users from a database? So there are some steps. So if I take you to the Blackboard, you need to understand that whenever you need to make a new API call or request to a server, first of all, you need to, in your server I'm defining, you need to have your server running. So for that you create a server application. It can be an express application. It can be a fast API application, basically whatever library you're using to create servers easily, because very rarely we create servers from the scratch using HTTP protocols. So we use these packages called Express, Fast API, and Django. So define an app for these services. Then you define your routes. So that means app.use some routes, let's say /user, /post, /organization. So these are the routes. So define these routes, and then you also connect your database to your app. So like you can define Mongo is equal to MongoDB in this URL. That means the URL of the MongoDB server as is at this location. And then you switch on the MongoDB server. And after that, you can start listening app.listen on a particular port, let's say 3000. And then you have a try catch block. So if any error occurs in starting this server, it will be caught. So now in a very high level language, I've explained this. Let me take you to the code. So in the same repository, 16 fetched users.js, you can see that first of all, I've created a simple Express application over here. App is equal to Express. I define the port on which I want to run my server. JSON, that means so that I can work with JSON in my server. MongoDB.connect, so my database is connected. User schema. For now, I'm putting everything in this one file, but it can be in a separate file. This is my user schema, name, age, and email. And then I'm registering my model with Mongoose, using Mongoose in MongoDB. And then this is my simple get call. Okay, this will help me fetch the users from my database and listen my server. So very simple, one single file to run a server, Express server in just 45 lines. Read it. In real production grade application, the structure will look a bit different. You will define everything in a different file. You might be using an ORM, object relation manager, for defining your schemas of your database. You can see this. This is an these are the schema of my tables using an ORM. I'm using Prisma ORM, and then you will be using this Prisma service to start it so that it registers your database. I mean, start your database, connects to your database, and then you will have everything in a separate file. But over here, just for sake of simplicity, I put everything in one single file just to show you. This is how you will write a simple API call to test it, and you can put your endpoint once your server is running, and then you can also check the code from here and try to make it a call and test it. Okay, great. What's the difference between a GET request and a POST request in terms of data handling? Very simple. We have already seen this is the GET call. In the GET call, you do not pass any body, right? You can only pass some parameters. So over here, you can see this is a parameter that I'm passing. This is a query parameter because I've given a name to this parameter ID. I can also write like organization name, let's say 67 is the organization ID. And after that, my some other thing, let's say slug for a blog is like AI evaluation, something like this. So these are my parameters, right? These are my parameters, and this is a query parameter. Okay, this is how you write a GET call. You do not define any body, but if we talk about POST call, you can either define query parameters, you can define parameters, plus you can also define the body. Okay, this body will be sent to your database. To your server. Okay, great. How would you prevent a backend API from crashing if a database connection fails? Okay, so 18th file you have to go into, and over here again I've done the same thing. I created my Express app port I defined, but what I did when I tried to make a connection with my database, I wrote a function for connect with retry. In my previous function, I just tried to connect to my database once, right? Over here. If it fails, it goes to the catch. But in 18th, I'm trying to reconnect, right? We can define maximum retries, 5 retries, right? And I'm defining a delay. So after every retry, it will increase the delay by 2000 milliseconds. So 1000 means 1 second, right? And it will try to retry to connect to your database. It will again call this function. But if it fails, then it will go to your else, and it will say database connection failed after multiple attempts. So this is how you can actually you should actually write your database connections so that it retries to connect. Okay, this is code I'm giving to you. You can read it, understand it, and that's it. Let's go to the next question. Explain what caching is and how it can improve the performance of a backend system. Okay, so if I go to my Blackboard, okay. So what caching is this is your client, right? And what you are trying to do is you're trying to fetch the same data again and again, right? This is my server, right? And this is my database. Okay. So let's say you are trying to fetch a blog again and again, right? Again and again, you're trying to fetch that blog, or you're trying to fetch your own profile again and again. Let's say Justin Bieber, right? So Justin Bieber's profile, like every day, a lot of girls and a lot of boys will be opening his profile, right? So it makes a lot of sense that his profile can be cached. How is caching different? Either you can store your data in disk, or you can store your data in memory, in cache memory, right? Cache memory is near to the CPU, so that's it can easily be fetched and it can easily be presented to the user. So that's why you have one main database and you can have one cache database, right? You can have a cache database. Cache data means like a hash map. So if you have already studied this hash map data structure, it is like key value pairs, right? So for key value pair, let's say followers of Justin Bieber is already stored over here. Let's say 240 million, something like this, right? So even if you want to, so even if the client, that means boy or girl, wants to fetch the how many followers Justin Bieber has, it will go to the server. Server will not go to the database and tries to count how many followers Justin Bieber has. Server will go to the cache database. It will check whether followers of Justin Bieber are saved in this or not. If yes, it will get it very fastly and return it. If not, it has to go to the database, tries to count all the people who are following Justin Bieber, and then before going to the client, it will save it in the cache and then send it to the client. So that next time if anyone tries to fetch followers of Justin Bieber, it can fetch it from the cache, right? So this is how in cache you can save some data, key value pairs. So you can use Memcached, you can use Redis for saving data in caches. So I've already given one example. I think I have not. Okay, no worries. I'll attach it in the same folder. Okay, but you have understood what is caching. Whenever you want to fetch some things very fastly and frequently you want to consume some things, either instead of like you can save them in the disk in the main database also, but with that you also save that data in your cache database like Redis and Memcached, so that it can easily be fetched. And the main like fundamental behind caching is in cache memory things can be easily fetched because the cache memory sits near to your CPU and it can easily be fetched and presented to your client. Okay, examples are Redis and Memcached. Great. How would you log errors in a backend application and why is logging important? So for this, I'll directly go to the production application over here. So you can see that in my source, in my utils, I have a logger folder. Logging is very important. You can, if you want to like increase your observability, you can, to impress your employer, you can actually give this example that you will use some advanced observability and analytics and logging tools like Prometheus or Grafana log or Grafana, and all of these tools you can use. But if there is a cross questioning, then you might not be able to answer. So stick to the concept that you already are aware of. So yes, these tools are for production grade observability and analytics and logging, but on your server itself, you can improve your logging by using Winston package in Node.js. Okay, so if you see in the logger.ts, I have imported this Winston package over here. You can check the corresponding examples for Go and Python. For Node.js, I prefer using Winston. So what this does is, whenever you have any log, it can be success log, info log, warning log, error log, you can also log it very beautifully in your terminal. Plus, you can also save the error log specially in your database. So what I'm doing, I defined my two types of loggers. Production logger, because for production logs itself only, I wanted to save my logs in my database. For development logging, I only wanted to see my logs in my terminal, right? So if it is a production logger, then you can see for development logger, it is fine, right? You can colorize it, you can beautifully log it. But for production logging, I am logging it in my terminal. Plus, I'm also sending my logs to MongoDB. So you can see MongoDB transporter I'm using from Winston itself. And over here, you can save your logs in your database also. And how to use it? So if I show you a repository, if I show you organization repository, you can see I'm using logger.error. And this logger is not a normal logger. If you check this logger, it is actually a Winston logger, right? So that if I am in production environment, it will log it to my database. If in dev, it will log it very beautifully in my terminal. So that's how you can handle logging in your production application, backend application. So this is the next question. How would you design a scalable URL shortening service like Bitly that handles millions of requests per day? So let me go to the Blackboard. So you need to design a URL shortening service like tiny URL, Bitly. Even LinkedIn does that. Whenever you post a link or a image, like any object that you upload on LinkedIn, it converts into a short URL, right? So your functional requirement is that you will provide a long URL to your service. This is a long URL, and your service should be able to convert it into a short URL. This is a very simple function of your API server, right? Next thing is it should be able to redirect. So whenever you have got a short URL, right, and user clicks on that short URL, the user should be redirected to the long URL itself, right? This is another function that there should be the correct redirect from short to long URL, right? And if you want to increase its functions, then you can have analytics on the short URL clicks, views, and all of that. Okay, let's forget that. So this is the functional requirements. For non-functional requirement, it should be scalable. As in the question, it is given that it should be able to handle millions of users. So scalability. It should be latency should be low. So low latency. It should not be very slow. That you click on the short URL and after a minute you are going to the long URL. Yeah, on a high level, these two are the requirements. So our service, our system will look like this, that you will have an API service, right? You will have an API service. The main function of this API service is to hash long URLs into smaller short URLs, right? So you need to use hashing algorithms. So the question can be on this, that which hashing algorithms you can use. So you can give a very basic example that you can use a base 62, right? So study more about these hashing algorithms, which takes a very long URL and converts into a short URL, short string basically. So base 62 is a very famous hashing algorithm. Then you will have a load balancer, right? Because scalability, right? So scalability we need to take care of, load balancer. And instead of one API service, you will have multiple API services. You will have multiple API services. Okay. Then you will have a database. You can think about it. This database should be of hash map like data structure, database. Why? Because we have a key value pair. We have a short URL and we have a long URL corresponding long URL, right? So you can use a key value like database. And the best example is cache databases, which is Redis. So you can use a Redis database because most of the times your users will be clicking on the same link and you want to access the same long URL for that short URL. Okay. So you need speed, you need speed in your system. So cache databases are very fast because the cache memory is like located very near to the CPU. So it is faster to fetch the result from cache database rather than using a disk database. So load balancer request will come over here from the user for create or get URL. It will see which service is up and which service is free and available. It will check out, and then the service will go to the Redis database. Either it will create a new short URL and save it in the Redis, or it will fetch the long URL for a short URL, and it will return it, and the user will be redirected. So this is on a very high level. This is the architecture. I'm not going very deep because a separate 1-hour video can be made on this. But if you explain this and if you talk more about the hashing algorithms, you are all set. Okay, let's restrict this topic till here because 2 hours video can also be made on this. Okay, great. Next question. Explain the trade-offs between monolithic and microservice architectures in terms of deployment, scalability, and maintenance. So monolithic and microservice. Okay, so there are many points on which you can differentiate between these two architectures. So these are just architectures, right? Architectures for creating apps, writing servers, right? So one thing is which one should you choose? Or first of all, what are they? So in monolithic, what you do, you have a application, right? So if you're defining or writing all your services in one single app, in one single code base, let's say for e-commerce you have user service, payment, order service, product service, cart service. So if you have written all the API services, all the services in one single code base, that's called a monolithic, right? You have one single code base, right? You have one single code base. On the other hand, if all of your services are independently deployed, that is independently, you can say independently deployed, that is microservice. Because what you did, you divided your complete application into small services, which is called a microservice. Okay. Deployment, if we talk about deployment, as I told, single deployment, it is independently deployed. Scalability, monolithic scales as a whole. That means even if the traffic is more on your payment service, you have to scale up your complete app, which doesn't make sense. Okay. In microservice architecture, you can scale independently. Okay. Whatever service is getting more traction, scale that up. So you can easily use horizontal scaling there. Next is maintenance. Monolithic maintenance is complex because you have to take care of all the services together. In microservice, you can turn by turn, you can maintain different services. So easy maintenance. Okay. Next point will be on complexity. So the complexity of monolithic is simple actually, because you have one single code base and you have to maintain one single code base, and it is simple, right? Microservice is complex. You have to take care of the communication that is happening between various services, right? How these services are communicating with each other. So complex. Next thing will be fault isolation. Very important point. Fault isolation is not present because if there is a bug in one single service, that is user service, your complete app is going to go down. In microservice, it is fault tolerant because even if there is a bug in the payment service, all the users can view products, they can see their cart, update their cart, but they cannot make the payment. So yes, we can say it is fault tolerant. I think this is enough points that you can talk about in an interview. Rest, it can be which one will you choose. So ask the interviewer what is the problem statement, and for that you need to make a decision whether to go with monolithic or microservice architecture. Okay, so this is the next question. How would you architect a real-time chat application backend to support thousands of concurrent users? Concurrency is there. Chat application real-time, whenever you see like real-time chat app, real-time conferencing, so WebSockets and WebRTC are the two keywords that you need to include in your system architecture. Okay, so one thing is, let's go to the blackboard. So architecting a real-time chat application. So let's list down the functional and non-functional requirements. So for functional, you need real-time messaging. So real-time messaging. Let's for now include just one-on-one chat. Let's not go into group chat. One-on-one chat. Second thing can be your user presence, like the dot you see, right? That green dot, online dot, or online thing you need to show for every user. Third will be a typing indicator, like if anyone is typing, so dot 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 typing indicator. This is your next feature. And end-to-end encryption. This even if you don't explain this in your interview, that is fine, unless explicitly asked. Okay, so end-to-end encryption. These are your functional requirements. Non-functional requirement will be your high availability, like chat should not be down. You want to chat with your girlfriend, you should be able to do it at any point of time. So high availability, low latency, right? Next will be your fault tolerance. So if something goes wrong, your app should not be down as a whole. And next case can be security. So these are your non-functional requirements you need to list down in front of your interviewer. So for high level architecture, we know that we will have a server that will be upgraded from HTTP to WSS, that is web server socket, right? So it needs to be upgradable server. So, and we have your client over here, and definitely you can have a load balancer for handling the multiple users at once. you can have multiple services, right? So I've already explained that. So let's just worry about this one single server that is upgradable to WebSockets, a WebSocket server. Whenever your client, so let's assume, because it's one-on-one chat, so let's assume two clients. Whenever one client hits this server, chat room server, let's say you opened someone's chat, so basically you have joined that chat room, right? So this should be notified. This server basically gets that event, like customer A or like user A joined the chat room with the chat room ID and user ID. So now one person is sitting in that chat room. So this is an event for the server. Now the server emits one event to all the clients that are available. So kind of you can highlight pub sub model over here, right? Pub sub model you can highlight, and socket you can highlight. So till now two tech keywords, pub sub and socket. Okay, so as soon as the server receives this join event, it will emit an event to all of its subscribed clients that hey, user ID 1 has joined this chat, and for this user ID it will show online. So that's how you do the online thing using WebSocket, that as soon as someone has joined, your server gets that data and notifies all the clients that have subscribed that hey, this person has joined the chat. Okay. Similarly, when any user starts open the keyboard and start typing like A, B, C, an event is sent to the server, and server notifies using the PubSub model to all of the subscribed clients that hey, user ID 2 has started typing, and typing will be shown in front of that person's username. So till now both the two features are done using WebSocket event and state feature. Now real-time messaging is again the same. As soon as you okay, I'll change the color. Yes, so as soon as someone has written the message, and let's say this person user 2, this is one user 2, user 1 and user 2, let's say user 2 clicks on the send button, the server will get that data and it will notify all the other subscribed clients that this message has been received from user 2, and this is the message tag. And on the backend, this server will also save that message in the database for that user, for that chat room, okay, and the message text or the message image or message link, whatever. So this is how your real-time chat app work using WebSocket. You basically have to take care of the PubSub model, so event and states, and your WebSocket upgradation. Okay. End-to-end encryption, well, I'll not teach in this video. A separate video can be made on that. High availability, basically you can have multiple servers doing the same task, right? Multiple servers doing the same task, and plus you can have a load balancer so that your availability is high. Even if one server goes down, you have other two servers doing the same thing. They are also WebSocket upgradable. And security we have not talked about in this video. Okay, so I'll not talk about security in this question. That's a separate topic. Yeah, that's it for this question. So the next question is like, what strategies would you use to ensure high availability in a distributed system? Okay, so multiple points over here, not just one point. Even like if this question is asked to you in the interview, you can list all of these things. One is like infrastructure level strategies. Infra level strategies. Okay, so on the infrastructure, what will you do? First of all, you will do multi-region deployment. Multi-region deployment. That means you need to keep your service highly available, right? High availability. So if you deploy multiple clones of your service in multiple regions, let's say one service is deployed in regions with geographical regions. One service is deployed in, let's say, US East. One service is deployed in Delhi or in Bangalore, right? One service is deployed in Dubai. So what you are doing, you are trying to create multiple clones of your service in multiple geographical regions. So if one service is down, your load balancer can check that and actually redirect your traffic to the service which is up. There is one more advantage to this. I'll come to that. So this is like one thing. So multi-region deployment you have to talk about. It ensures failure in one region does not bring downtime to entire system, right? One thing. For this, you can give an example of AWS Global Accelerator that takes care of this global deployments. So that's a good example. It will show that you are skilled in AWS also. Okay. Next can be load balancing. So right. So if there are like three servers in your system, and you have defined a load balancer, and if this is like fully occupied, you can redirect your traffic to other two servers, right? Instead of going on this service. Load balancing. Okay. You can give an example of ALB, automatic application load balancer, sorry, and you have NLB also, a network load balancer, right? So you can give these two example. This actually loads the balance the loads on network level and on the application level for ALB. Okay. Next is like DNS based load balancing is also there. You can search that. Next is like auto scaling. So you can use AWS auto scaling groups, ASGs they are called as, right, which actually handles the auto scaling of your system on its own. Because if you have let's say a chat service, and suddenly there is something, and 1 million people are using your chat service, ASG will automatically scale this up, horizontal scaling or vertical scaling. It will use that, and it will automatically scale this service, and 1 million users can easily chat. Next is data layer strategies. Previously it was infrastructure level strategies. Data layer strategies. So over here, one is database replication. Let's say you have one database. So do not depend on one database. You should always replicate your data. So because of something like one service is down, one database is down because of something, other can be up. So you can use cockroach database. One database can be responsible for only the writes, and one database can be responsible for the reads, right? So such cases you can use these strategies to handle all the failure cases. You can have distributed caching layers, right? This is called replicas. Then you can have caching, right? Instead of your service is going directly to your database, right? Don't go to the database directly, go to your cache database, right? In case of like, tiny URL or that URL shortening service we saw, or in Instagram, some people are like very famous. So we need to frequently fetch their profiles. So store them in a cache database, right? That's on data layer. Next is like application level strategies are also there. Application. So you can use like rate limiting. Okay. So yeah, some examples you can give in the application level strategies. Then you definitely have some, so basically if you want to keep your system available, you need to keep on monitoring it, right? So you can give example of observability, that you will use these tools, logging, analytics, right? Prometheus, Grafana, and all of these tools you can give, and you can basically keep on monitoring your system whenever it is required to make them available and scale them up. So yeah, overall like this much is enough. Even if you like give these examples, infrastructure level strategies, data layer strategies, and application level strategies, they should be enough. And then a cross question can be there on one strategy. Okay, great. Next question is design a rate limiting system for an API that restricts user to 100 requests per minute. So I've already written the code for this. Basically, you need to rate limit the system. You must have seen this in GoDaddy. So what happens? GoDaddy uses, as far as I know, IP address based rate limiting. Like if you are searching for so many domains, like you search for 10 domains in like 1 second using some system, so it will rate limit you. Like it will block you. Your IP address will be blocked for let's say 30 minutes, right? This is useful because some people are just doing DDoS attacks, or like they are just trying to extract all of your resources, scraping all of your resources. So for that, rate limiting is very important. And for that, I've already written the code 25 rate limiting.js. So first of all, you can use Redis for that, because in Redis you can maintain the count of how many requests have been served for this IP address, right? So what I've done is I've defined my Redis client, port and host. Then this is my rate limiter function. So first of all, I'm getting my request. I'm getting the request count. If this request count is greater than the rate limit that I've set, which is like 100 requests per minute. So 60 is the seconds and 100 is the number of requests. So if it is greater than or equal to, I will send the status code 429. Too many requests, try again later. And if this is not the case, like person can still make the request, then I'll just increment my Redis client key by 1. Okay, I'll just increment my key by 1. And if this is the first time, then I'll just set my key for the first time in my Redis, initialize my key with count as 1 because this is the first time the request has been made. And I'll set my expiry to 60 seconds, that is window size 1 minute. Very simple, right? And you have exception handling, and then you switch on your server and it's ready. So just using Redis and defining your rate limiting number and your time expiry, you can have your rate limiting in your system for any API or any route. That's it. Okay, so this is the next question. How would you handle database schema migrations in a zero downtime deployment? Okay, so the meaning of the question is that you already have a database table. Migrations are usually there when you are working with SQL databases. So let's say this is your table in SQL, right? And this is an employees database, let's assume. And over here you have the employee first name, you have employee last name, you have age, and you have gender, right? Now this is going very well, and tomorrow like your requirement has changed and you want to add a new column over here, right? And the column is to store the date of birth of the employee, right? So you know that you need to migrate your database, you need to run a migration so that a new column is added, right? So in such cases, what you can do is you can tell your interviewer that, hey, yes, I'm going to basically whatever changes I'm going to make, I'll make sure that they are backward compatible, right? So for such cases where you have to add a new column, what you can do is, so two cases, either you have to add a new column or you have to you have to change the column name. Basically, like you want to change your column name, you either want to delete your column, right? Which is a rare case because you will let it be there, right? You want to delete it, let's assume. Yeah, mostly these are the three updations that you want to run on your SQL database, right? So the changes, whatever changes you do, you need to make sure that they are backward compatible. So in this case, what you will do, you will add a new column, but you will define it as nullable. So for adding a new column, you make that new column as nullable. So that, let's say from till here all the rows are there, 1 2 3 4 5, and over here at the 6th row you want to add this new column. So if you will not make it nullable, all of these what will happen to all of these empty spaces, right? So SQL will run a problem over here and it might not migrate successfully. Migration might fail here. So if you want to run the migration successfully, you have to make this column DOB, date of birth, as nullable, so that all the previous values are by default set as null. Okay, that's like one thing. Next thing is, if you want to shift it, and whenever you like run a migration, you do not put it to production at that instant itself. You release a version that's usually like beta version, alpha version, then beta version, and then when you see that, hey, nothing is breaking, then you put it to production on a certain deadline or a date, right? So this was for add. Now for shifting, what you will do, let's say you want to like call this gender column as male, is male, right? This is the new column name that you want to keep for gender. So for a new column, what you will do, you will create a new column. It will be nullable for sure for at the initial level, and then you're going to backfill your values. You're going to backfill your values slowly. Like all the values from gender will be put in is male column. So this is also done in parts. Like you do not run all of the migrations all at once. You first create a new column, check if anything is breaking, the column is nullable, then you start backfilling the values to your new column, then again you release it and then check if it is breaking anything, and then you can set it to production. So basically the funda is that you do it, you check, and then you do the next change, right? So there are some I just gave you a very high level overview, but the technical term for this is rolling migrations. Like basically you are running migrations in a rolling format. You're not migrating the whole system or SQL table all at once. You are just making the changes in a rolling format, right? So yeah, I think this much is enough. But yes, I have given the answer on a very high level. You have to go deeper into this migrations thing because this is a whole separate topic in itself. Okay, great. Explain how would you design a content delivery system. This is my favorite question. I love CDNs, content delivery networks, right? With low latency for global users. So content delivery system. So let's go to the Blackboard. So content delivery systems. Okay. So content can be of two types. It can be either static content, it can be either dynamic content, right? So for static content, what you will do, and yes, you need to make sure that your latency is low and all the global users are happy. Okay. So whenever there is a term called global user or geographical location, so you need to make sure that wherever your users are, let's say my users are in sitting in Dubai. So what you need to do is your server or your database or like your whole system should be nearer to the users. If the system is in US, right, then to go to the US server and bring the data back, it will increase the latency, right? But if you keep a cloned server, if you keep a replica of your main server in Dubai itself, then your latency will decrease, right? So our purpose of low latency will be done, like it will be achieved, and all your global users can be served very well. Because if these users are sitting in New Delhi instead of Dubai, you can set up a server in Bangalore, you can set up a server in Mumbai, right? Which is nearer to Delhi in comparison to Dubai and US. So in this way, if you set up replicas of your main server in various geographical locations, you can easily serve your global users at a very low latency. So this is a concept, and this is called like in AWS we do have a global accelerator, we have a CloudFront, right? So in cloud, we also have Cloudflare, we have Akamai. So these are some of the tools, cloud providers, which actually make all of this possible. So all of these big companies like AWS and Cloudflare, what they have done is they have set up their servers all across the world in various continents, in various countries. So in this way, if you use the service of these cloud providers, let's say Netflix uses AWS, right, for their streaming. That's why whenever you go to Netflix and click on a video, it starts playing immediately because the video is stored nearer to your geographical location, right? So that's why these cloud providers are earning in millions, because they have made it possible by setting up all of these servers across the globe, right? So this is like one thing where you are using global accelerators. So one thing is you are using global accelerators, like you are using servers spread all across the world, global servers, right? And the answer for this is, like, some of the tools is AWS CloudFront. So these tools, if you tell to your interviewer, you will have a very good impression. You can use Cloudflare, right? You can use Akamai, right? So this is like one solution, right? And these accelerators handle your static content and your dynamic content both, right? Static content means your images, videos, like textual content, all of that, like in blogs, right? In dynamic, you might have to worry about the streaming, video streaming, like in Netflix and all. So that is global accelerator. Next is load balancer. So what will happen, because you need to at the end achieve low latency. So what over here can happen, let's say your user is sitting in Dubai, right? And you have implemented this global accelerator by setting up 3 servers in Dubai, right? Cloned replicas of the main US servers, right? So what is going to happen? Your load balancer will check the user location, and as the request will come, the request will go to Dubai servers. But because of some reason, these Dubai servers are occupied and they're not available right now. So the load balancer should automatically redirect the request to US server, because at the end, yes, low latency is not achieved over here, but at the end the user should be served somehow. The user want to see the response, right? So it should be automatically gone to US and it should be handled. So that is like another way. Third thing is your database replicas. So till now we saw the replicas of our servers, which are able to store the global content, like your images, blogs and everything. So that is different thing. But I'm talking about the database replicas. So if there is a user in Dubai, so his data should be there in Dubai itself. It is better to save it in Dubai, because some nations have some compliances. So that will also be achieved, and low latency will be achieved. And yeah, these are like main advantages, right? So this whole concept of storing the data and content nearer to the user is called edge computing. So This is another technical term that you need to tell to your interviewer. So yeah, that's it. I think we have covered everything for this question. What's the difference between horizontal and vertical scaling? And when would you choose one over the other? So yes, we do have two types of scalings, right? One is horizontal scaling and another is vertical scaling. So let's go to the blackboard. So horizontal scaling, and I think you already know what are they, but the question over here is when will you use what, right? So one thing is horizontal scaling. Let's say you have made a social media application, and till now there are only two users in your application, right? You and your friend. So for this, yes, you will just have a 2 GB RAM computer, 2 GB RAM, and you will only have, like, let's say 2 GB of storage. So 2 GB RAM, 2 GB storage, right? Very small computer, will cost you like 5 rupees, 10 rupees a day. That's it, right? So that's it. But let's say you did something, you just created a very unique feature, and suddenly this number multiplied by, let's say, 1000, right? Now all the 1000 people are chatting at one single time, at one single instance, right? So you have either two at this point, or that is also fine. But now the lag has started coming, and the CPU utilization is like 100%. There is no memory left in your CPU. So you have two choices. You can either set up a new computer, right, running the same instance, same code, and you attach it. So basically you have two servers running the same thing. So some users request will go to this, some users request will go to this. But because still your scale is very less, like 1000 users, there is no like, doesn't make sense to have two computers and handle two computers, right? So in such cases you can go with vertical scaling. Instead of a 2 GB computer, you go ahead with a 4 GB computer, 4 GB RAM computer, and 8 GB storage, right? It can easily handle 10,000 users also. 10,000 users also. So till 10,000 users, it is totally fine. But now let's say you did something very amazing and now you have 1 million users, right? So in such cases, vertical scaling starts failing, because you cannot have an infinite number of RAM in a computer, right? You cannot have, let's say, 2 TB RAM, because if you try to do this will be costing you like millions of dollars in a year, right? So in such cases, you can go with multiple servers. You will say, but in over here also we have to handle so many computers and it will cost that much. No, it will not cost that much. Why? Because when you have so many users, all the users might not be using your app at a single instance. There will be spike times. Let's say at night, your spike times increases. Like a lot of folks start using your application at night itself. So in that night time itself, you will be consuming all of your computers. But in the afternoon and the morning time, these computers will be idle and they will not charge anything. And only these two computers will be charged, right? Because will be charging you, right? Because you are using cloud, right? You are using a cloud provider, and auto scaling, which will automatically scale your system, right? You can use Kubernetes for that. You can, which will it automatically orchestrate your containers. So in such horizontal scaling system, which is very good for scaled up applications, it is really amazing for scaled up applications and to save cost. Vertical scaling are good, but up to certain scale. So up to certain scale, this is okay, right? Similarly, when you are using like SQL databases, when we talk about database scaling, so when you are using SQL, for that vertical scaling is good, is better than horizontal. Why? Because SQL databases are stored in tables, right? So when you want to run a query on a whole table, you have to basically somehow use sharding, and you have to see how you will attach the results of all of these tables, all of these database clusters, right? In terms of vertical scaling, you have only one big computer, one single server. So all of your complete table is present in one computer. So when we talk about SQL, you have to make some trade-offs and you have to check which one is better for you. Scale, you have to look into which type of database you are using, that you have to look into, right? So yeah, these are some of the questions, cross questions you have to ask your interviewer, and then only you will be able to come to a conclusion. How would you design a notification system that supports email, SMS, and push notifications with retry mechanism? So this is a coding question. Basically, you can give a very simple architecture, but I chose to give you the code itself. So here is the code, line 29, file 29, and over here I've written the very simple code. So just see what I'm doing. I have not written any notification code because you might be using Twilio, you might be using Firebase notification, or you must have you might have like your own notification system, push notification system, like MoEngage and all of these tools are there. So you can either use that, but basically the concept over here is, so if I show you like a very basic architecture diagram, just a minute. Yes, now I can write. So you will have a client, right? You will have a client, which let's say just there can be multiple notifications. So you need to tell the interviewer that what type of notification you want to handle. Are we handling payment notifications? Like you just paid something and you want a notification. So payment notification and email, because that you expect very quickly, right? You cannot wait for the confirmation. Payment notification. Next can be OTPs. You cannot wait for more than like 10 seconds for receiving an OTP, right? Then you might be having marketing campaigns, right? Which nobody is interested to know. Okay, marketing emails and marketing SMS can be there, right? So I think usually these three types of notifications can be there, and one can be like updates or push when hey like WhatsApp, like someone messaged you, right? So this can still have some delay, like a minute or two. Okay, but OTP and push notifications, OTP and payment notification should be top priority. So in such cases, you have to tell the interviewer that you will have a client. Then you are going to have an API gateway, right? You will have an API gateway. And over here, you definitely need to tell about a messaging queue. Messaging queue. So you know queue data structure, right? So that's the same concept over here. Things first in, first out. Let's say someone paid, right? Someone did a purchased some product, so he needs to be sent a notification. So request will go to the API gateway, and we definitely have a database over here which is going to store our notifications. And we do have a server over here. There can be multiple servers. We can have a load balancer. But for now, let's keep this much, right? So for messaging queues, you can use like AWS SQS. You can use Kafka. You can use RabbitMQ. You can use that. So these are some providers for messaging queues. So you just paid, so your request will go over here. API gateway will send the request to /payment service, right? So it will go over here, and it will also trigger a notification. So service will say, hey, we need to send a notification. So it will save the payment data in your database. It will save the data of notification in your database, and a trigger will go to your simple queue service queue, right? So in the queue, there will be an event that, hey, Akshit has paid and he needs to be sent a notification. Similarly, tens of thousands of people would be paying at the same time. So similarly, it is going to start entering in your queue. So as you know that in queue first in, first out, so it will just pop one element, and hey, this is a notification to Akshit with the metadata. This is a payment notification, or this is a OTP notification, and it will directly go to the client. So something like this, it happens, and definitely you have a notification sender. So it will not, Kafka will not send a notification. Kafka will just trigger an event to this notification service, and this notification service can be like Firebase, it can be anything, and this is going to trigger a notification using your device ID. So every client has a device ID on which you can send a notification or an email, then it will go over there. So this is a very high level architecture, and this is the code for that. Like if it is an email, so you can either have you can also have scheduled notifications, right? Plus you can have retries. If somehow the notification is failing, then you can again put the event in your queue, right? So over here, what I'm doing in retry, I'm just trying to add the correct notification event to my queue, and as soon as the queue takes the event and pops it out, and then it calls the send notification function, which is over here, which is taking whether the notification type is email, SMS, or push, and then it basically send the notification. So I've not written the code for sending an email, SMS, or push. That depends on your provider. But overall, this architecture, if you explain to your interviewer, and if you just give these lines of code, 20 lines of code, even if you don't write this, just explain this, I think it should be enough. But yeah, I think that's it. Again, this is a very big topic. A notification is not like a 5-minute topic. So go ahead and watch it if this excites you. But yeah, that's what I wanted to cover. Describe how do you implement a load balancer from scratch and handle session persistence. Okay, we need to implement a load balancer from the scratch. So first of all, you need to understand what a load balancer does. What are the key features of a load balancer? What is the architecture of a load balancer? If you do this, then I think you will have a very good impression on your interviewer. So let's go down, and over here, first of all, let's understand what are the key features of a load balancer. Key features of a load balancer. So key features of a load balancer. Number one, it should be traffic distribution. Traffic distribution, like it should be able to distribute your traffic. So if your clients are there and you have like 2, 3, 4 servers and you have a load balancer, so load balancer should be able to distribute your traffic to the available server at that particular time. Second is your health checks. So load balancer keep on checking which server is up, which server is down. Next is session persistence. This is a very important topic, session persistence. So what happens if I am a user, if I'm a client, and I have, let's say we have 2 servers and we have a load balancer over here. Now, if my request went to this server 1, then for that session, it should always go to 1 for this client. So if I have 2 servers and we have created a load balancer, so for that session, for that user, the request should always go to server 1. Because server 1 will only have initial session information about this request for that user. If it will directly go to your second server, it will not have any idea. Because what happens, yes, I did say in this video itself that servers, REST servers are stateless and they do not store any state. But what happens when you have multiple servers in your system, right? They might be connected to some databases, right? You might have multiple databases, right? So when your client makes a request, and we do have a load balancer, in very simple terms, load balancer is nothing but it is just a normal server. It is just a typical server. The task of this server is just to redirect the traffic, right? So when the client makes a request and load balancer chose to go ahead with the first server, so it will be connected to this database, right? So for that session, the database will be connected to this. But at the end, after some time, the data should be there in all the databases, so that if tomorrow the user comes and makes a request to the second server, load balancer shifted to second server, and this load balancer is connected to this database, so it should be having information about this user, right? But that can be done later. So for that instance, for that session, it should persist the data, and that task is for load balancer, that for that session the request should always go to server 1, right? Make sense? So this is session persistence. And last is failover handling. We do have one more, sorry, not last. Failover handling, that means if this server goes down at some time and the requests were coming to this server, the request should start coming to the other servers. So that can happen in round robin, like first request will go to this, then this, then this, then this, then this. So like a round robin kind of mechanism. Or next mechanism can be LRU, least recently used. Like if this server has been like least recently used, then the request will go to this. After this was least recently used, this will go to this. The request will go to this server. Okay. So these are some techniques using which you can select which server to choose. Load balancer can select which server to redirect the traffic. Okay. So on a very high level, this is just the architecture, and I do have the code for this. So this is the code, guys, for load balancer. So basically we have 2 servers which we need to manage. So one running at 3001 port and second running at 3002 port. So these are my list of servers. Currently it is set to 0, the first index. So this is a proxy, create a proxy server I'm creating, http proxy.create a proxy server, right? So you need to learn what is a proxy server. So I just created a proxy server, create the load balancer server. And this is my server, which is a load balancer server, right? So just http.create, so as a normal server you create, right? Proxy means on behalf of, like in college, at the time of attendance, you put the attendance of some of your friends, right? So that means you are doing a proxy. That means on behalf of someone else, you are doing some task. So that's why this is a proxy server. On behalf of some other server, it will do the task. So this is what is meant by proxy, right? So create a load balancer server. So this is just a normal HTTP server. It takes a client IP, so that for that IP it should maintain the session. It should persist the session. Use a simple hash function for session persistence. So I created a hash, just converted the client IP to a hash, and just mod servers.length, so that every time you do this, because hash of the IP will always be same. So whenever you do a mod with the servers.length, it will always like same output will come, same integer will come out, right? Because you are finding a mod with the two same integers, right? So same output will come. So we'll get the server index. It can either be 0 or 1. Then proxy.forward request to the selected backend, right? So whatever backend you chose, either port 3001 or 2, you have to forward the request from this load balancer to your server which you selected right now. So proxy.web request and response. Target will be this URL, which is this. In real cases, you will have a real URL, domain name. Console.error, if anything goes wrong, write head 500 if this goes wrong, and end the server if this goes wrong, right? Otherwise, if this is not the case, error has not come, it will redirect your request from client to your server which you selected, right? Just switch on the server, and this is the function for finding the hash. That's it. So this is a very simple code for creating a simple load balancer which balances the load between two servers. I hope you understood this. So that's it. I wanted to cover these 30 questions itself in this video. You need to understand that this is just the first part of this complete series. I do have 31, 32, 33. I do have almost 70 questions which I'm not teaching in this video, because all of these questions are intermediate and hard level. So I want to create a separate video for this as like system design, master system design, or master advanced backend. So that's why I just covered these 30 questions for this video, where we have covered like basic to intermediate level questions for backend mainly, and bit of system design. But the next 40 questions are going to be completely system design based, and little bit of backend. So I'm for sure I'm going to give you the code for those videos or for those questions also. But I hope you enjoyed this video. I'm going to launch the next video on the other 40 questions which I have, as you can see, as soon as I get 200 likes on this video. So do share with your friends who are preparing for backend and tech interviews, software engineering interviews. Backend is like usually asked only. So I hope you enjoyed this video. I hope you like more videos like this. So do let me know in the comment section if you want the next part soon. So hit the like button and share with your friends. Also, when you are learning this video, do give me a shout out on LinkedIn that hey, you are watching it, so that I also know that whatever I'm investing time on, it is actually worthy. Okay, so thanks guys for watching this video. Till the next video, keep coding, keep innovating, and thanks a lot.